Hey guys, what is up? So my name is Faris. Um, so today I will be recording a video. Um, I'm gonna show you a problem in power systems course and how to get the answers using software. Um, the software that we will be using is called MATLAB. There are several ways that we can get the answer from simulation. And one of the ways is using MATLAB. The other ways is using PSCAD. Even in MATLAB, we have two different ways. We can use Simulink or we can use the coding method. So in this video, I will be showing you the the coding method. So first, we look at. So this is our assignment, the problem. A three-phase line with an impedance of 0.2 plus J1 ohm per phase feeds three balanced three-phase loads connected in parallel. So the data given is load 1 absorbs a total of 150 kilowatt and 120 kVAR. Load 2 it is a delta connected with an impedance of 150 minus J48 ohm per phase. Load 3 we have 120 kVA at 0.6 power factor leading. If the line to neutral voltage at the load end of the line is 2000 volt, this means the magnitude of the line to line voltage at the source end of the line. Okay, so now we will be opening our MATLAB. So here we click new script and the new script will pop up. Alright, so to solve this, to use this method, we will be coding and there will be several lines, which is to me quite long because I am a simple person. I like it. I like things to be short. So I have written the coding beforehand. So this is the coding. Let's copy and paste it. Control C, minimize, Control V. Alright, so from here we can see the given data. The impedance of the line, we call it as Z line, is 0.2 plus 1J times 1.0. So here we write it like this because it is how we tell it in MATLAB. So this is the S1. S1 stands for the S for loop 1. So we have 150 kilos. Exponent 3 is 10 to the power of 3 and 120 kilo. So the impedance for load 2 is 150 minus J48. Oh, I forgot to mention why we have to divide this by 3 because the S is the total for the system and we divide it by 3 because we want it to be per phase. For impedance at load 2, we divide it by 3 is because we want to convert it from delta connection to Y connection as it is stated here. Look here. Delta connecting. Okay. So for S3, this is the S for loop 3. Calculations were made and this is the final answer. for S in load 3. So as we can see from here, the calculation for S3 is 120 over 3, 120 over 3 kilo VA, kVA, angle negative invert cos 0.6. So 0.6 is our power factor. And here we use negative cos because it says that power factor is leading. So after the calculation is made, we get 40 kVA, angle negative 53.13, and the final answer would be 24 minus J32 kVA. So back here, the voltage flow stated in the problem is 2000 volt. So now we have to find I for each load. So I, the current for load 1 is conjugate S1 over V load, the one we stated here. This is because we use the formula S equals to VI conjugate. So for the current in the second load, we can use V load over Z load 2. We can get this equation from the formula V equals to IZ. For the current in the third load, we can use conjugate S3 over V load. It is the same as the first current in first load, which is we use the formula S equals to VI conjugate. So the total I, it would be I1 plus I2 plus I3. So here you can see this is the hand calculation for each current. You can see here. You can pause the video if you like. So this is the current in second load. You can pause the video if you like. And the third, and this is the total current. So in order to find V line to line, in order to find line to line voltage, we first need to find line to node voltage. So line to node voltage, we can use the formula V load plus I times Z line. So here, this is the load voltage, which is 2000, plus total current times the impedance of the line. So here it is a volt, and here V times V equals to IZ, so I times Z equals to V, where we can get the line to node voltage. So if we want to find line to line voltage, after we got the line to node voltage, so we can use the formula square root of 3 times line to node voltage. Why do we have to time it with square root 3? Well, because this is the V line to node, and if you want to convert it to line, we have to times the voltage with square root 3. So the magnitude of the line to line voltage at the source end, we declare it as V underscore magnitude equals to absolute value of V line to line. Why did I put the absolute here? It is because the answer here is coming from here, and the answer from here is coming from all of this up here. Not all. Will be coming from this and this. As you can see, we have the imaginary part in here, and here also we would have imaginary part. So to get the magnitude of V, we have to declare absolute here, so that it will only show the real part of the voltage and not the imaginary part. So the display result, to display the result, we can type in DISP, magnitude of line to line voltage at the source end. So here we put it here, we put this words here to show the words from here, to show the numbers from here, and then we put volts. Right, so before we can run, we need to save it. Don't mind the test run. So we save it as my matriculation number 22000123. Save. MATLAB will not be able to run the file. Alright, so we have that settled up. Let's run. Oh, so we do not have a valid name. What if we save as? Alright, save. So the reason I choose F is because it's my name for this. So now let's run. Alright, so the results should be out here. So we got the magnitude of line to line voltage at the source end as 3478.7192 volts. So is it right? So let's compare with our hand calculation. So our hand calculation shows that our V line to line is 3478.72, which is correct. So that is all for today's video. I hope you guys understand, and if you guys don't understand, you can comment down below and I will reply to you as soon as I can. Bye bye.